Hello Pre-Calc BC. We are moving on to day 9 notes, the real zeros of a polynomial function. And this stuff I really like. I think it's really fun. So I hope you enjoy it too. All right, so, the factor theorem. This is something you learned about last year. Basically, it says that x minus b is a factor of a polynomial if and only if p of b equals 0. So essentially, if you plug a number into the function and you get a 0, that means that it is a factor, basically meaning we have an x-intercept. If the remainder is 0, then the binomial is a factor of the polynomial, and we can use something called synthetic division to factor higher order polynomials. There's also something called the rational root theorem, and what it does is it identifies possible zeros for you. Now, I'm going to be honest, this is not as helpful to us now since we have a graphing calculator to find our zeros for us. But what this does is kind of narrow down what your options are. Okay, but it would have been more helpful before the existence of graphing calculators. So basically, this just identifies what the possible zeros could be, and we do factors of our constant over factors of our lead coefficients, and that's p over q. Okay, so let's go ahead and get started. Determine if x minus 2 is a factor of f of x equals 4x to the fourth minus 15x squared minus 4. So there are two ways that you can do this. Okay, the first way is to take 2 and plug it in for x. So 4 times 2 to the fourth minus 15 times 2 squared minus 4. So that would be 4 times 16 minus 60, right? 15 times 4 minus 4. And that's going to be 64 minus 60 minus 4, which is 0. So this is a yes. Okay, so now they've told you to factor completely. So if you have to factor completely as well and not just say if it's a factor, then synthetic division is probably the way to go, because synthetic division will help you identify if it is a factor and then help you factor completely as well. So here's how we do synthetic division. You're going to put your 2 here. So everyone sets this up a little differently. I do it like this. My numbers up here, but you do need to leave placeholders. So this is 4x to the fourth, 0x cubed, negative 15x squared, 0x, and then negative 4. So that's how I set it up, but some people set it up, I think, like this. So it doesn't really matter. It's just, I would say, do what you want to do. So here's how this works. Your first coefficient comes down, 4, and then we multiply to the number in the box. 4 times 2 is 8. And now, unlike long division, we are adding. 0 plus 8 is 8. 8 times 2 is 16. That's a 1. Again, we're adding. Multiply to the number in the box. 2. Add them together. Multiply the number in the box. 4. Add them together. 0. This last spot tells you your remainder. Since your remainder is a 0, that means it's a factor. Okay, it divided evenly. It also means that x equals 2 is an x-intercept or a 0 of this graph. So now we can factor completely. What you have left over, each of these are the coefficients of your function. So this is the constant. This is 1x. This is x squared. So you just kind of work your way out, and this would be 4x cubed. And now usually you can factor this. So remember what we said in the past, try grouping. So I'm going to say, I'm going to take out a 4x squared from both of those, and I'll have an x plus 2 left. And then I already have an x plus 2 here, and that GCF would just be a 1. So when I factor f of x, I will get 4x squared plus 1, x plus 2. Now what we just did was factor this part, but we're factoring this. So you also need to have your x minus 2, which was the original factor. Because now if you look at it, you get 4x squared times x. That's where your 4x to the fourth is coming from. So here is your factored form. All right, let's keep moving. For each problem, we are going to list the maximum number of real zeros, the potential rational zeros, we'll factor completely, and we'll give the solutions. And we can use our calculator for this as well in order to help us. Okay, now your max number of real zeros is just referring to the degree of your equation. Which is 3. There are going to be 3 total zeros. There could be a real zero and 2 imaginary. This lesson is just focused on real zeros, so we'll hit imaginary starting in our next lesson, I believe. Okay, but 3 is the total number of zeros you'll have, and of course that means it's the most real zeros you could have. Now for your potential rational zeros, which is a mouthful, so I'm abbreviating, this is your plus or minus p over q. So p is your constant and q is your lead coefficient. All right, and this is factors of p and factors of q. So factors of p, well, we have 1 goes into 20, 2 goes into 20, 3 does not, 4 goes into 20, 5 goes into 20, 10 goes into 20. Okay, that should be it. And then q, well, it's just a 1, so right there. So what that means are the potential rational zeros, meaning the possible x-intercepts, are now, we divide them, plus or minus 1 divided by 1 is 1, plus or minus 2, 4 over 1 is 4. Okay, and yes, you need the plus or minus for all of them. Okay, so here's what would happen back in the day before the graphing calculator. You would have all of those options, right? And then we wouldn't know which ones were actually x-intercepts. So then you would get to synthetically divide with each of those values until you actually found the ones that worked. Doesn't that sound like fun? Okay, but we're not going to do that. So what we're going to do instead is actually graph this. X cubed plus 8x squared plus 11x minus 20. Zoom 6. Okay, and then just draw a little sketch for me. It doesn't say that, but just do it anyways. Something like that. And what we can see from the graph is that there are 3 x-intercepts, so we have 3 real solutions. And what you're just going to do is your second trace 5 to find each of them. Second trace 5, enter, enter, enter. Oh, I forgot to mention, if you're going to do that, you have to put in a 0. Second trace 5, enter, enter, enter. All right, so the first one is at 1, which you'll see was one of our options. Second trace 5, move this way. Enter, enter, enter. Negative 4, 0. And then I believe the next one is a negative 5, 0. I'll have you just confirm that for me. Now, if you have all of your x-intercepts accounted for, there is no reason for us to do synthetic division. What we can do instead is just factor completely from the graph. So I have 3 total solutions here, and all 3 are represented on my graph. So I'm just going to go straight to my answer. F of x equals, well, if I had a negative 5 as a 0, I'm going to have an x plus 5. If I had a negative 4, it's going to be an x plus 4. And if it's a 1, it's going to be an x minus 1. Okay. Also, each of these intercepts, see how we're crossing? We're going through each of them. That's why each of these are a degree 1, and that makes sense because when you add them up, you get a total of 3. So here is our factored form, and then your solutions, you're literally just going to list your x-intercepts again, but just the x value is fine. Okay, so there are your three solutions. Let's try it again. All right, so max real zeros. Again, that's just your degree, so this is 3 again. And now we're going to find the potential rational zeros. And that's plus or minus factors of P over Q. And again, P is your constant and Q is your lead coefficient. So factors of 12. We have 1, 2, 3, 4, 6. Oh, and 12. It's important. And factors of 2, we have 1 and 2. All right, and now we'll just go ahead and divide them. So 1 over 1 is 1, 2 over 1 is 2. So I'm just going to divide everything by 1 first. And then I'll divide everything by 2. 1 divided by 2 is 1/2. That's a new one. 2 divided by 2 is 1. I already have that. 3 divided by 2 is 3/2. That's a new one. 4 divided by 2 I have. 6 divided by 2 I have. 12 divided by 2 I have. All right, so it should just be these guys. So these are my options, and now I will go ahead and graph. And 2x cubed minus 5x squared minus 4x plus 12. All right, now it looks like you only have 2 zeros here, but notice that this one is bouncing, so that does mean we have 3. This is a degree of 1 because we're crossing. Bouncing is degree of 2. So we do have 3 all together here. Let's go ahead and sketch. And then we can find our intercepts. So we have a negative 1.5. Notice that's the 3/2 right there. And then this guy. A lot of times when you do second trace 5 for a bounce, it won't work. Sometimes you get lucky. Okay, see how it went back to the other one? So what you would have to do is use minimum, or you can just you can literally count. Because I mean, we know what the options are, right, from potential rational zeros, and so you can see that that's a 2. That's a 2! Oh my gosh. All right, so there you go. So again, all of your intercepts are accounted for, so we can go straight to the factoring without doing synthetic division. All right, so I can say x plus 1.5 and then x minus 2, but x minus 2 has to be squared because there is a bounce here. Now, here is the problem with this. If you were to FOIL this out, it would have a lead coefficient of 1, right? X times x squared, that's going to give you an x cubed. This is a 2x cubed. So what you do have to do is put a 2 in front, and then you're going to distribute it to that x plus 1.5. Because let's be honest, you never see something written in factored form like that, right? So that becomes a 2x plus 3 x minus 2 squared. And now look, when you solve it, you're still going to get x equals negative 3/2, which was our solution. But now you have the right coefficient. So here's your factored form. Okay, we're going to cut number 4 for time, but I am going to display the answers briefly, so if you'd like to do it on your own, you can. And here. All right, these last two are going to be a little bit different, because I feel like the last ones have been like more of the same over and over again. Okay, so let's do our max real zeros. That's going to be 3 again. And our potential rational zeros, P, Q. Okay, factors of P, or factors of 28. 1, 2, 4, 7, 14, 28. Did I miss any? I don't think so. Factors of 3, 1, and 3. Okay, so divide everything by 1. It's just that whole top list again. And I don't care about order here. And then divide everything by 3. You've got 1/3, 2/3, 4/3, 7/3, 14/3, and 28/3. And I'm going to move that over. Don't you wish you could do that? Okay, so what's your next step? Graph. X minus 28. Okay. Well, so here's the thing. This is all we got. Some of these numbers are a little bigger, right? It does go all the way up to 28. So let's just expand our window. X max, or actually X min and X max, right? Because it was plus or minus 28. So let's go 30 to 30. Maybe it hits somewhere else. No, it did not. It just hit right there. Okay, so here's where it can be nice to look at these, is that it tells you like, oh, well, maybe I need to change my window and look bigger. In this case, it didn't matter. Your graph looks like that. I mean, it don't look exactly like that, but close enough. All right, so second trace 5, enter, enter, enter. 2.33333. So 2.33333 is 7/3, I believe. And now this is when you're going to need to use synthetic division to factor this. Okay? We only have one of our solutions. What that means is the other remaining two are going to be imaginary. So 7/3 is what we will do our synthetic division with. 3, -7, 12, -28. Now, when we do this, we should get a remainder of 0. If not, we have a big problem, because what our calculator just told us is that 7/3 is an x-intercept, which means that we should have a factor here. 3 times 7/3 is just 7. -7 plus 7 is 0. 0 times 7/3 is 0. 12 plus 0 is 12. 12 times 7/3 is 4 times 7, which is 28. And add them up, and 0. So now remember, the number closest to the remainder is the constant. So this is 12 plus 0x plus 3x squared. And that we can factor further by taking out a 3 and getting this. Okay, so when you factor completely, don't forget about your 7/3. X minus 7/3, and then 3 x squared plus 4. But then what we're going to do, because like this doesn't look very nice, is we are going to distribute this 3 to the x minus 7/3 so that we no longer have a fraction. So that's 3x minus 7, x squared plus 4. Here's your factored form. Notice when you do this, you do still get an x equals 7/3 as your solution, which is great. But now this one actually has those two imaginary solutions, right? So I told you we're going to talk about imaginary tomorrow, but this is just, or next lesson, but this is just a little prequel. we would go ahead and set this guy equal to 0. Subtract our 4 over. Square root both sides. And remember, when you have square root of a negative, we say that that's I. And so x would be equal to plus or minus 2i, because the square root of 4 is 2. 3 solutions. Okay, which brings us to our very last problem, number 6. And let's skip the potential rational zeros and the max real zeros part, because I feel like we've done that for all of them. Let's jump straight to the graphing, factoring, and solving. So 2x cubed minus x squared minus 23x plus 30. Okay, so I have 1, 2, 3 solutions. That's good news because I did have an exponent or a degree of 3. Okay, so that's, they do all cross. Second trace 5, enter, enter, enter. 1.50, okay. Do it again. Second trace 5. Oh, I don't know what that is, do you? Let's look at the other one. Nice try. I don't know what that is. Okay, so these guys are like unknowns. What does that mean? It means that they weren't rational zeros. Okay, those must be irrational. So what do? Synthetic division. You've got one real zero, or excuse me, one rational zero, so we can do synthetic. Bring down your 2. 2 times 1.5 is 3. Add 2. 2 times 1.5 is 3. Add negative 20. Negative 20 times 1.5 is negative 30. Add, and we'll get a 0. This will become 2x squared plus 2x minus 20, which we can pull out a 2. Good to know, thank you. And then we can factor completely. So there's that. Don't forget about your x minus 1.5, the original. And then what we're going to do with our 2 is we are going to distribute it to the one with the decimal, like we have done for some past problems. So that will give you a 2x and this guy. Now, for the solving, the 2x minus 3, we know that x is just 3/2. But what about this guy here? What are you going to do with that? How are you going to solve that? We are going to use good old quadratic formula. All right, so x equals opposite b plus or minus square root of b squared, so that's a 1 squared, minus 4. My a value is 1, my c value is negative 10, all over 2 times my a value is 1. That's a 1 plus 40, which is a 41 over 2. And you can leave it as exact. I'd actually prefer that. But check this out. This is really cool. If you type this into your calculator, negative 1 plus square root 41 divided by 2. Look at that. Does that look familiar? Negative 1 minus square, gosh, I'm struggling. Square root 41 divided by 2. Those were the two numbers that we got. when we graphed it. The ones that we didn't know. Look at that. See? Negative 3.7, negative 3.7. Pretty cool, huh? All right, let me know if you have any questions. Have a great day.